All right, now that we've done chapter 13, where we've used our derivative to figure out certain features of graphs, increasing, decreasing, mins, maxes, concavity using our second derivative, now we're going to talk about how we can also apply derivatives to figure out things like finding an absolute maximum value or an absolute minimum value. If you want to optimize something in business, in science, anything, we can find the absolute maximum or minimum by using our derivative. So instead of a relatively high point, what is the highest point in our function? We're also going to talk about what we call implicit differentiation, where we differentiate when we have multiple variables, so not just x's anymore. If we have x's and y's all scattered throughout our problem, how can we still find the instantaneous rate of change, or the derivative? We'll talk about that. And the last thing we're going to do is what we call related rates. Related rates are, I'm sorry, but word problems, some application problems on how we can figure out how things are changing depending on other things changing. One of the popular ones is, I don't know, a ladder falling down the wall, and the side here is going to change, and the ladder falling down the wall is going to change. And so we're going to talk about all different sorts of rates of change, derivative, in application problems. So how we apply derivatives, kind of cool. So in chapter 4, we're going to do sections 4.1, 4.2, 4.4, and 4.5. So we skip section 14.3. Making sure, again, as usual, you print off the blank chapter notes at the beginning, or you upload them to your tablet. You watch the video and you complete the notes as you're watching the video. And I highly, highly, highly suggest you pause, you rewind, you rewatch, you try the problems on your own first, before always having me guide you through. It's much easier when I do it for you. It's a lot harder when you actually have to think about it and do it yourself. So please make sure that you're trying those problems yourself. I've used the analogy in the past. It's like riding a bike. You can't say that you know how to ride the bike if I always get you on the bike and push you to get you started. You've got to be able to get yourself on the bike and start to pedal before you can say you know how to ride a bike, right? So same idea. I need you to get started all on your own with these problems and get yourself going before I'm guiding you through it, okay? All right, make sure that you submit your completed notes in the chapter completed notes section, and then make sure as you're doing your test, you're showing all of your work and you're submitting that in a clear single page document. Make sure that you do your homework, make sure that you do your review with at least an 80%, but the more you do, the better you're going to do on your test, I promise. And then let me know if you need anything along the way.